All right, today we are going to tackle one of the biggest, most fascinating concepts out there, intelligence. We're going to peel back the layers, move past the simple labels, and really look at the engine under the hood, from the very wiring of our own brains all the way to the future of AI.
So let's just start with this question. What does it actually mean to be smart? Seriously, is it about acing a test, knowing a ton of random facts? As we're about to find out, the real scientific answer is so much more dynamic and interesting than just a single number or a label.
Okay, so let's dive right in. First things first, we need to get on the same page. What are we even talking about when we use the word intelligence?
Well, from a scientific point of view, it's this: a system's ability to make good decisions, to learn, to adapt, and to solve problems. And notice that last part, to achieve goals. It's not just about thinking. It's about thinking for a purpose, effectively, in all kinds of different situations.
You know, even the word itself gives us some major clues. It comes from Latin, and it's built on two core ideas. First, interligere, which means to choose between. That right there tells you that decision-making is at the absolute heart of it. But then there's intelligere, meaning to gather from between, which is all about understanding connections and seeing the bigger picture. So it's both choosing and understanding. This image here, it shows you the whole concept in a nutshell. Just think of any intelligent system, a person, an animal, an AI, as a kind of black box. It takes in information from the world around it, right? That's the input. And then it does something. It produces a behavior. That's the output. Intelligence is all the magic that happens inside that box, the process that turns what you see into what you do. Okay, so for more than 100 years, scientists have been obsessed with this idea that there might be a central, all-purpose engine for our minds. So let's get into how this idea of general intelligence actually works.
And that brings us to something called the G factor, which stands for general intelligence. The theory is that there's this broad, underlying mental horsepower that affects how well you do on pretty much any cognitive task, whether it's solving a math problem, understanding a poem, or figuring out a puzzle. Think of it like the central processor, the CPU of your mind.
So what's this G factor made of? Well, it's not just one thing. It's more like a toolkit of a few crucial skills. You've got your working memory, how much information you can juggle at once. You've got attention control, your ability to focus and tune out distractions. There's cognitive flexibility, how easily you can switch gears. And of course, abstract reasoning, the power to see patterns and connections. Now, this G factor shows up in two main flavors. First, there's fluid intelligence. That's your raw, on-the-spot problem-solving power for things you've never seen before. Then you have crystallized intelligence. That's your library of stuff you've already learned. Facts, skills, vocabulary. Basically, you use your fluid intelligence to build up your crystallized intelligence over your lifetime. This all raises a really interesting question, right? If we all have this core engine, what makes some systems more powerful or faster than others? So now, let's look at the actual mechanics of what makes for higher intelligence.
And what's so fascinating is that higher intelligence isn't really about having a bigger brain, but a more efficient one. I love this subway system analogy. A more intelligent brain has really well-organized, optimized connections. Information just gets where it needs to go faster, and it uses less energy to do it. It's all about efficiency.
So how does this efficiency play out? Well, a key process for fluid intelligence is called attentional integration. When faced with a really complex, new problem, a highly intelligent brain does this four-step dance. First, it breaks the problem down into smaller, simpler chunks. Then, it focuses its attention on just one piece at a time. After that, it starts linking the relevant pieces together, figuring out how they relate. And finally, it assembles all those linked parts into one coherent solution. It's literally like building a jigsaw puzzle in your mind.
And this isn't just a metaphor. Researchers describe it in exactly these terms. They say the mind integrates these little cognitive fragments into a complete computational structure. That process is thinking, and being able to do it quickly and reliably is a huge part of what we call high intelligence. But here's the thing. If we only focus on that G factor, we're really missing a huge part of the story. So we need to zoom out now and look at the entire incredible spectrum of intelligence. Because the truth is, intelligence isn't one single thing you can just measure on a simple scale. It's more like a vast landscape, a whole array of different skills and abilities that have evolved for all kinds of different purposes. For example, you've got analytical intelligence. That's the logical, problem-solving stuff that IQ tests are pretty good at measuring.
But then you have creative intelligence, the amazing ability to come up with totally new ideas, to think outside the box.
And then there's the really human stuff, right? Social intelligence, that knack for navigating complex group situations. And its close cousin, emotional intelligence, which is all about empathy, self-awareness, and managing emotions in yourself and others. Both are absolutely critical. And intelligence gets even bigger than that. It isn't just an individual thing. Just look at swarm intelligence. You know how an ant colony made of simple creatures can produce incredibly complex, intelligent behavior? And then there's collective intelligence, which is what happens when a group of people, often with technology, work together to achieve something no single person ever could.
So, all of this, it brings us to the future. Where is our understanding of all this heading, especially now with AI in the mix? Well, the destination might just be a new kind of shared intelligence.
One of the most mind-bending new theories out there is called active inference. It basically says that intelligence isn't just about solving problems, it's about a fundamental drive to confirm your own understanding of reality, to gather evidence that your model of the world is correct. And what does that mean? It means that curiosity, the desire to explore and reduce uncertainty, is a built-in, essential part of being intelligent.
This idea gives us a kind of roadmap for where AI could go. You start with sentient AI, systems that are just curious about the world. From there, you get sophisticated AI that can think about what it knows and doesn't know. The next leap is sympathetic AI that can understand what others are thinking. And the final goal? Shared intelligence, a true ecosystem where human and artificial minds are collaborating.
Which leaves us with one last massive question to think about. We've gone from the nuts and bolts of what intelligence is to all its different forms, and now to its potential future. If we actually manage to create a global ecosystem of shared intelligence, it's not just going to change our tools, it's going to fundamentally change who and what we are. So what will we become?